Ayubowan. Now I am going to talk about very special thing, some deviations from general knowledge. What is that? In generally, we know in chemical kinetics we talk about simple things, zeroth order, first order, second order, third order, likewise all are integers. ඔක්කොම පූර්ණ සංඛ්‍යා තියෙනනේ. Orders, every order is are whole numbers, integers. However, if in the examination, if you face this type of thing, a to the power is 3 over 2 or 2 over 3 or 5 over 7, any fraction, ඕනම භාගයක් මේ විදිහට දුන්නොත් the power is a fraction, not a whole number. At that time you will confuse. ඔයගොල්ලෝ confuse වෙනවා ඉක්මනට exam එකේදී. මේ වගේ එකක් දුන්නොත්. So how to do this? Very simple. Only thing you have to know is the integration part. Doesn't matter it is whole number or a fraction. භාගයක් හෝ පූර්ණ සංඛ්‍යාවක් ඕන එකක්. The theory is same, but don't confuse. The method is this. Stay with me. I am Hasan Kalungarachi. Okay, this is the question. This type of question will come. I don't know. I can't assure, but there is a probability. Normally, in general, we know A plus B will give products. If this is an elementary reaction, that means single step or මූලික ප්‍රතික්‍රියාවක් නම්, the stoichiometry is equal to the order. So if I write down an equation, rate law, dA divided by dt minus equal k, a to the power, here order will be 1 and b, order of b will be 1 because this is an elementary reaction. The stoichiometry is equal to the order. If the stoichiometry is 2 with respect to A, here order will be 2. If the order, if the stoichiometry of B is 3, here order will be 3. However, if the order or stoichiometry is 2 over 3, in this type of equation, the order will be 2 over 3. There is a probability to come this type of question, and they will ask, derive the integrated form. So how can we integrate this type of question? Very easy. Okay, I will write down from here. Minus dA over dt. However, here I have to think about, there is a mistake here. What is that? When we write down rate expression, we have to think about the stoichiometry also. You can remember that. There is a common equation flow, plus or minus concentration of something by dt. Here we have to divide by stoichiometry. So here this should be modified as minus stoichiometry is 1 over 2 over 3. We have to divide. Okay. Here negative sign. Don't forget this negative sign, and is equal to K, concentration of A, and if this reaction is an elementary reaction, the order will be 2 over 3. Okay. This is the basic thing. Now we have to integrate. Before integration, we can rearrange this part. Minus here 2 over 3. 3 is the denominator. I can rearrange this equation as minus 3 divided by 2. This 3 will goes to up, okay, and here dA over dt equal k a to the power 3. Okay, now how can we integrate? Before integration we have to rearrange. How? We have to move, we have to keep concentration terms in left side and all the other terms in right hand side. So I will move this concentration term to left side and all the other, this 3, 2 and dt will move to right hand side. Okay, minus dA, this concentration term will come as the denominator because it is now multiply. When it come to this side it will be a division, බෙදීමක් වෙලා එන්නේ. Okay, equal k, this dt will go and this 3 over 2, when 2 division 2, when it's moved to right hand side it will be a multiply 2 and this multiplication 3 when it's moved to right hand side it will be a division. Okay, I rearrange the equation. Now I can integrate very easily. Okay, how can we integrate? I will introduce integral mark. When I introducing integral mark, what should we concern? Negative signs, negative and positive signs we can't integrate, and integers and constants we can't. That means numbers and constants we can't integrate. So 2 over 3 and k both all are constants, so we can't integrate them. So I will put integral mark like this, minus 1 over here a to the power 2 over 3 dA equal here 2 over 3 and k all are constants, so integration of dt. I can integrate only t because there should be d term to integrate. Here initial concentration is A naught, final concentration is A. Okay, now I arrange the equation. I will rewrite that equation here, minus here A naught, here A 1 over concentration of A to the power 2 over 3 dA is equal 2 over 3 k dt 0 to t. Okay, now how can we integrate? Very easy. Here doesn't matter whether it is fraction or a whole number. එයා භාගයක් වුණත් පූර්ණ සංඛ්‍යාවක් වුණත් ප්‍රශ්නයක් නැහැ. It is a power. Here 2 over 3, this term is a power of A. එයා ඒගේ බලයක් විදිහට තමයි ඉන්නේ. So however it appear as the denominator. ඒක ලවයක් විදිහට ඉන්නේ මෙතන. 1 over A to the power 2 over 3. How can we integrate? You know this. If we integrate 1 over A, it doesn't have a power. Answer will be, if we integrate this by dA, answer will be ln A. However, we can't use this rule to this because this A contain the power. මෙයාට බලයක් තියෙනවා. බලයක් තියෙන ඉන්න මේක දාන්න බෑ. So if anything has a power, we can use the power rule of integration. What is that? A to the power n or x to the power n. If we integrate by dx, answer will be xn plus 1. We have to add 1 and we will divide that power plus 1. This is the answer for this power rule. However, if you have this type of question, 1 over xn, now we can integrate this xn. It is as the numerator. ලවය විදිහට ඉන්න කෙනෙක් තමයි මේ විදිහට දාලා ගන්න පුළුවන්. It is a numerator. Here it is denominator. මේක හරය විදිහට ඉන්නේ. හරයක් අපිට මෙහෙම ගන්න බෑ. So we have to rearrange this equation. We have to get this x in denominator as the numerator. අපි ආව හරය ලවය විදිහට පත් කරගන්න ඕන. කොහොමද කරගන්නේ? When I rearrange this xn, x to the power n, this is positive n, when it become numerator ලවය විදිහට එනකොට මේ ධන ලකුණ ඍණ වෙනවා. x minus n, and we can write this type. Now it is a power, doesn't matter, it is negative. ඒක ඍණ බලයක් තමයි, කමන්නේ බලයක් කොහොම හරි. Now we can apply this power rule. How? X minus n plus 1 divided by minus n plus 1. This is the answer. Simple. The only thing is negative sign. Doesn't matter. Now same thing we can apply for this. Here minus, don't forget minus sign, and a naught to a. Here dA equal 2 over 3 k dt 0 to t. There is another important thing you have to remember. When we write down these steps, sometimes we will miss this negative sign. You will forget to apply negative sign. When you come this step to this, you will lose this negative sign. Don't forget that, okay? You have to put negative sign, and also this 2 over 3 value. Sometimes you will forget to enter that 2 over 3 value here. You put that here, but when you do go to next step, you will forget that. Don't forget, okay? Everything you have to remember. After doing your calculation or deriving this integral form, recheck your answer. What are the missed parts? Okay. Now I will arrange this equation, this denominator I will represent as numerator. What will happen? Now a goes to numerator. එයා හරය ලවයක් වෙනවා. එතකොට මොකද වෙන්නේ? minus 2 over 3. It will become minus 2 over 3, and here dA integrate a naught to a equal 2 over 3 k. Here what is the result of this integration? We know we have to deduct. අපි අඩු කරන්න ඕන ඉහළ සීමාවෙන් පහළ සීමාව. We have to deduct lower limits by upper limits. So here 2 over 3 k, upper limits t, lower limits 0. Answer will be kt minus k0. So answer will be kt. So here answer will be kt. I integrated that part. It is very easy. Okay. Now we can use power rule. Answer will be, we have to put answer inside the bracket. A minus 2 over 3 plus 1 minus 2 over 3 plus 1. Okay. A naught to a equal 2 over 3 kt. Okay. Now how can we simplify this? I will erase these parts. So I will simplify this minus 2 over 3 plus 1. So 3 common factor. Minus 2 okay, answer will be 1 over 3. Okay, A, now it is 1 over 3 and lower parts also 1 over 3. A naught to A equal here 2 over 3 kt. Now I can simplify again this 1 over 3, I can rearrange equation as 3a it's somewhat messy. I will write another color. Equal 3a. If I do a mistake, please leave a comment, okay? Sometimes I also made some mistakes when I am doing these calculations. A naught to a equal 2 over 3. However, method is okay. I am telling you the correct method, but in calculating there may be some mistakes what I made. I am not a robot, no? Okay. Okay. Now I have to deduct lower limits by upper limits. I will erase this. Here, now did I miss something? Here the negative sign also, negative sign. Did you see that? I missed negative sign, negative sign. Here also negative. That's why I said we have to carefully observe the steps after we did, after done. Okay. Now I will deduct lower limits by upper limits. Upper limits minus 3a. This is the upper limit, 1 over 3 power. We have to deduct lower limits minus 3 a naught 1 over 3 equal 2 over 3 k t. Okay. Minus 3 a 1 over 3 minus minus will be plus, and 3 a naught 1 over 3 equal 2 over 3 kt. Okay. Now this minus 3 is common for both. Now I will get that common factor out, and within brackets concentration of A 1 over 3. Here I got minus 3 out. Now here remaining minus concentration of A naught and power 3 equal 2 over 3 kt. Okay. I will rearrange equation. Minus 3, here it is act as multiply minus 3. I will rearrange the equation. I will divide equation both side by minus 3. Same thing. Remaining parts will be A final concentration 1 over 3 minus initial concentration A naught 1 over 3 is equal 2 over minus 9 kt. Okay. Here multiply 9 minus 9. Okay, this is the expression for but most of times they will ask expression for final concentration. If they ask expression for final concentration, if they ask final concentration expression, you have to derive equation for final. Here A is final concentration 1/3 equal, here minus A naught will goes to other side, it will be positive, A naught 1/3 minus here negative sign, and here positive, it will be negative, so negative 2/9 kT. This is expression for final concentration. At the same time, they will ask expression for K, rate constant. How can we write down that? K, it is very easy if we derive that from this equation. Okay. Now minus 9 divided by 2 T, here final concentrations power 1/3 minus initial concentration 1/3 equal K. This is the expression for rate constant, and same time they can ask expression for T. Very easy. Now T is equal again minus 9 divided by 2. Now K will come, and other parts are same. Final concentration to the power 1/3 minus initial concentration to the power 1/3 this is expression for T. So everything is very easy. The theory was you have to know the integration of power. See, very easy things. Okay. So what are the other important things in chemical kinetics? I will explain some important integral parts here. As a summary, in chemical kinetics, first integration you have to know 1. If I integrate 1 by someone dA, answer will be A. If I integrate 1 by dx, answer will be x. But we are going to integrate by someone, that someone is the answer. Okay, that's the first one. Second one, if I integrate 1 over something, 1 over x by dx, answer will be ln x. If I integrate 1 over a by dA, answer will be ln a. That's the second thing. This is first one, this is second one. Other one is the power rule. If I integrate x to the power n by dx, answer will be x n plus 1 divided by n plus 1. If I integrate a to the power minus, think minus 3, doesn't matter whether it is negative or positive, it is a power. So I integrate by dA, answer will be a to the power minus 3 plus 1 minus 3 plus 1. Okay, that's the third thing. These are the very important integration parts we are using in chemical kinetics. If you know these three things, everything you can calculate. Okay, what are the important logarithms? If log or ln, doesn't matter whatever it is. If I get ln a b, we can write down this as ln a plus ln a b, sorry, ln b. If they given ln a plus ln b, this is the answer, opposite side of this part. if they have given ln A divided by B, we can write down ln A minus ln B. Other one is very important thing. If we have log 10 to the base 10 for, what can we do? Or we have log a to the power n. We can get this power to the front of logarithms. So answer will be n log here 10 base a. Okay, these are the very important things we faced in this chemical kinetics lessons. So if you know these things, everything is very easy. Okay, so this is the summary, and remember this type of question, there is a great probability to come for this examination. Okay, that's it. So please subscribe my channel and share this video with your friends, and stay with me. I am Hasanka Kalingwarachi. Ayubowan.